Hi, today I'm going to be working on the 2018 Further Maths exam paper. I should be calling it General Maths Exam 2 paper. Question 3. This is a question on the earliest starting time, minimum completion time. So there are 10 activities A to J, and the first question says determine the earliest starting time in hours for activity I. Now, the earliest starting time is determined by the forward scan, and I have indicated all the edges that you have to make choices in blue. Now, that's where you have to be careful while doing a forward scan. So let's start. I put boxes at every vertex, and let's start with 0 at the start. And 0 plus 3 is 3. 3 plus 4 is 7, because I've come to that edge where you have to make a choice. Now let's go along B. 0 plus 2 is 2, and 2 plus along D, the duration of D, 6 is 8, which is the other choice. And of the two, 7 and 8, you choose 8 to be the bigger value, and you write it as the earliest starting time for activity for activity F. Now, as you come along activity F, 8 plus 1 is 9, because that's again a place where you're making a choice. I've indicated it in blue. And now the other choice will be as you come along E and G. So 2 plus 3 is 5, and 5 plus 5 is the other choice, 10. So between 9 and 10, we will choose 10. Now let's go along H and J. So 10 plus 3 is 13, and 13 plus 2 is 15. And as we go along I, 10 plus 4 is 14. Of the two choices, I will choose 15. And in the question, they have said that the minimum completion time is 15 hours, and this forward scan supports our answer. They have said write down the critical path. Now, in order to indicate the critical path, you have to do a backward scan. Now, the first thing, as I did a backward scan, as I've told you earlier, I indicate where I'm going to make choices, and as you go backwards, that was one, and that was another, and that was the third. And I have done my backward scans in orange. And so let's start with the last value, which is 15, which is the latest starting time. We fill in with the same value as the earliest starting time. And then we go backwards. Let's go along J and then come to H, which forms one of our choices. So 15 take away 2 is 13, and 13 take away 3 is 10. And we write it here as one of our choices. And if we go along I, 15 take away 4 is 11, which is the other. And in the backward scan, as you know, we always choose the smaller value, and that is 10, and we write it here. Now let's go along F and D. And after we finish that, let's go along G and E and then choose again. So 10, which we just filled in, take away 1 is 9, and 9 minus 6 is 3. Now if we go along G and E, 10 minus 5 is 5, and 5 take away 3 is 2, the other choice. And of the two, we choose 2 to be the smaller value. Now let's go along B. So 2 take away 2 is 0. And if we go along C and A, 9 take away 4 is 5, and 5 take away 3 is 2, the other choice. And the smaller one is 0. So we have now done the backward scan, and let's indicate. I have actually shown you the critical path, but let me go over how I found the critical path again. And so I usually add the earliest starting time to the duration to get the next starting time. I find that the safest way to get the critical path, and we usually look at all the boxes where the earliest and the latest are equal to each other. So 0, 0 plus 2 is 2, so that's edge B, and 2 plus 3 is 5, and that's edge E. and then 5 plus 5 is 10, which is edge G, and then 10 plus 3 is 13, which is edge H, and 13 plus 2 is 15, which is edge J. So that is the critical path, BEGHJ. Now it says 2 of the activities have a float time of 2 hours. Write down these activities. Now if you just look at the backward scan, you will know which activities these are. Sometimes it's easy. So if you look at activity A, the value at the end of the backward scan was 2. Now actually that is your latest starting time for activity A. So that gives you a float time of 2 hours. If you're not comfortable with thinking that way, then just use the formula, which is the latest starting time here minus the earliest starting time minus the duration time. So that's 5 minus 0 minus 3, and that will give you 2. Now if you look at another activity which is not on the critical path, because those activities not on the critical path will have a float time. And let us look at which activity could it be. Now if you look at those activities which are not on the, let's look at C. C is 9 minus 3 minus 4, so that's 9 minus 3 minus 4, and that's 2. So it is these two activities which have a float time of 2. So that is A and C. Now it goes on to say, for the next upgrade, the same project will be repeated, but one extra activity will be added. The duration of this activity is 1 hour, earliest starting time 5, latest starting time 12. So earliest starting time 5 and latest starting time 12. So we first have to find what the earliest starting time, where it says 5. And as we can see over here, the activity with the earliest starting time 5 is this one. And so it obviously joins here. But where does it go? Now I found that if we have duration and we have the latest starting time, we can add these two to actually get the edge from which it originates. So if it's 12 over here and the duration is 1, when we do a backward scan, 13 must have been the latest starting time of some activity, which when one was subtracted from it, gave me the latest starting time 12. So if the latest starting time of this activity is 12, so let's write 12 at this edge, because I usually write the backward scan values. Sorry, let me make that clearer. So let me join this, because earlier starting time is 5 from what they've indicated. And so end of E, 2, as I've explained, let's write 12 over here, which is the latest starting time for this activity. And this activity has a duration of 1. Let me call that ACT. And as I told you, this 12 is a value you can get when you do a backward scan along that edge, which means that the value should have been 13 sorry, I shouldn't be writing it that way. 13 take away 1 is 12, which is this value. So now we should find where is this 13 value that we're looking for. The latest starting time of which activity is 13. And so if you look at it, it is from here. So from the end of E to the beginning of J. I hope I've made that clear. It is a slightly difficult concept to understand, but once you start thinking that way, it should be a lot easier. So that is question 3 from the 2018 paper. I'll continue to work on question 4 because it is a slightly different Eulerian circuit question. It was an interesting one, and I've seen a question, minimum distance question, come pretty often in the exams. So this question says parcel deliveries are to be made to between 5 nearby towns, P to T. The roads connecting these 5 towns are shown. A road inspector will leave from town P to check all the roads. Now, to check all the roads, when you see this particular phrase, you have to think of traveling every edge once. And when you read and return to the same town P from where he started, you have to think of the Eulerian circuit. Now, he will travel the minimum distance possible. Now, when you see the minimum distance possible, you have to remember that all the edges should be added because he has to travel all the roads. And if there are odd degree vertices, those should be traveled again, repeated. Okay, so the minute I think of the Eulerian circuit, I will put down the degrees of the network on the diagram, and as I have done. And what I find is this edge and that one actually are the odd degree vertices, which has to be traveled on more than once. And so they've said how many roads. Often students make the mistake of actually listing the roads, P, Q, and ST. Please read your question carefully. They've asked you how many, so 2 is the answer. Now determine the minimum distance. So as I've explained previously, when they ask you to calculate the minimum distance, first you have to add all the edges. The sum of all these edges is actually 88. And then you have to repeat those edges which have odd degree vertices at either end. And that implies that you have to add 10 plus 12 to it, which is 22. And the total minimum distance he travels is 108. Hope you've learned something from that, and if you have any comments and you'd like me to explain anything more clearly, please leave a comment in the comment section. Thanks for watching.